Now I think I tap danced long enough for our next speaker. A very talented and innovative speaker. I'm not going to embarrass him too much, except that he was the winner last year of the Social Systems Design Innovator Award at the main event. Again, directed by Keith Nagara and co-hosted by LTU. A very talented innovator, future designer, alumnus of LTU. We'd like to see his latest version of the video, not mine. Mine was a bit more conservative. I think I like his better. Without further ado, Jason Polinsky.
Thank you. I am very excited today to speak to you all, not only as an alumni of our program here that you are immersed in, but as an instructor who was hired on his graduation day to come back and teach the underclassmen in how to use CATIA for design. Now, I don't know how much you guys know about the program here at Lawrence Tech, but it's going on its 6th year this year. So to look around the room and see the level of work on the walls being compared to schools, art schools, world art schools that have been around for much longer than 6 years, this school has a reputation already of developing very capable students who are getting hired in the work world, and that's very, very awesome. And I think it's in no small part to our using CAD as a foundation for what we're doing. If you asked what separates a Lawrence Tech designer from a designer from another school, the answer we use is designers with technical knowledge to maintain their design intent. Well, that's nice. Technical knowledge from Lawrence Tech, that makes a lot of sense. But what does it really mean? We have classes where we train our students in manufacturing processes, where we train them in rapid prototyping, we train them in the basics of engineering, in career development, but also the foundation from day one here as a designer is CAD. This is kind of comparable to how in the 1990s and the early 2000s engineers were started becoming more responsible for their own design work. They were making CAD capable engineers. Well, our program here is about making CAD capable designers. So the process that a lot of our students come in with is kind of what you see a lot in industry, where the designers, the 2D designers, do their sketch and rendering, and they're very much involved in the exploration phase. You've got your CAD surfacing, your EMM, your clay build groups who are more involved in the execution phase, but kind of involved in the exploration phase. And then finally, you've got the engineers that are just execute, build, mill, model, create the actual final part. Well, we see this with our young students who come in here and say, okay, well, in the beginning of the semester, I'm going to draw a lot, and then I'm going to start to put things in CAD. And for some reason, CAD kind of creates this sense of permanence to them. And we don't know whether it's a situation where they believe it to be difficult, or whether it's just actually seeing it in 3D in front of them, where they kind of tend to not want to go back and explore. It's, okay, this is what I drew, now I'm starting to execute it, this is what it looks like, I really don't want to change it, and then finally I've got my model that our freshmen build in clay, and our sophomores, many of them will actually see built as a rapid prototype. So what I'm trying to do is kind of build a very good basics in parametrics and design for change for our underclassmen, so that way this becomes more of a cyclical process that they can control. You have them start a 2D design, lots of pen and paper and rendering, where they begin to execute it in CAD, but they don't feel that the CAD becomes permanent. They can go back and explore in CAD and then create more 2D design work and just continue this process, basically narrowing it down until they have something that we're ready to show on the walls. How do we do it? Well, we start off with volumetric modeling and basic surfacing. That would be part design and GSD. And we teach our students about parametrics, basically how to design for change, how to create the objects on the screen, and the ones that you think you're going to want to change the proportion of as you go along, and make them formulas, make them relations, make them something that's easy to go back and modify if they decide, no, that's a little bit too big. They can do it tomorrow. They don't have to worry about, oh, well, I put that line there and now it's too hard to change, and so now my design's just going to kind of rely on that line that I don't really like. Moving on after that, we get them into Imagine and Shape. It's a very simple way to teach them some advanced surfacing. They get to put their hands on it in 3D. It's almost like 3D sculpting. They can sit there and pull points and create a volume on the screen that can be used backwards with their parametric models. If they want to do cutouts, if they want to do headlamps, if they want to do anything parametrically, this explicit surface can be the base surface, and if they make a change, all they've got to do, well, in CATIA is update, but if they brought it in from another software, they can just do a surface replace. So the first year, what we're trying to really target our students to learn how to do is the basic model, the sketch model. My freshmen last year did a very wonderful airplane project where I'd say the most complete model was probably about 80% complete. And that was great. They turned in this very complex airplane, just about all of them made some very complex airplane. And what they delivered to me was an 80% model that I told them to go back and Photoshop. And when they were all said and done, you would never have known, based on the input CAD model and the output of Photoshop, that these models weren't totally finished. They looked like the real thing. Some of them actually decided to go on and take their Photoshop model and turn it into a real finished 3D model once they had more time. One of the other things that I target is to teach them how to use CAD as a proportional study. Sometimes I had students who had a shape that was too complex for them to figure out how to draw and render on paper using good perspective. So we would teach them to build it in basic volumes, and CATIA also control those basic volumes with parametric dimensions. And that way they could sit there and control the volumes and the orientation and set that up on the screen, put that model where they wanted to take it, take a screen grab, and then sketch over it. Seems kind of basic, but it's one of those things that a lot of students wouldn't really think of using basic CAD for. They kind of tend to think CAD is the final result of all of my drawing, not something that I can use in the beginning or the middle. And then finally, of course, we have to make sure the freshmen know how to model, so we actually have them do quality models, finished downtown stuff that could be built on a rapid prototyper. Second year, we're trying to focus on using CATIA more as a design tool and help them speed their design decision making. A parametric wheel scaffold is kind of paramount here. Rather than have them design an entire wheel, we show them how you can use CATIA to mirror a simple quarter surface. Like say we're having them do a 5-spoke wheel. We'll have them design only a quarter of that wheel and have CATIA do all the hard work of mirroring it and then patterning it into a finished wheel, so they just have to focus on one little quarter of what they want to build. Also, some of the more tedious portions of it, second year we really get them involved in the package layout and understanding that they're designing their vehicle around a person. This is something that takes considerable amount of time in other softwares. Well, CATIA has the ability of making this parametric and updatable. You could sit there and put in your mannequin and your wheels and your layout and all of that stuff, and it's very simple for a student to sit down and make changes as they go in their design. Again, they don't find themselves constrained by the package that they picked on day one. And then last but most certainly not least, taking their models from any software they choose and turning it into something that they can rapid prototype, a quality model. Basically everything that you see in the room here in 3D went through CATIA at some point in order to get it ready for rapid prototyping. And the basis for all of what I just told you, sorry it's a little dry, was my senior project. This is what Professor Nagara really wants me to show you. What I did, let's see, it was 2 years ago this last summer. I was sitting there working in Ford, and this video came across my desk, the 1929 Fordson snow machine. Some of you are familiar with this video, and for those of you who are not, in 1929 they took these pontoon shapes, put them on the side of a tractor, and decided to try and make a vehicle that could last the winter. Basically a Model T with its skinny little tires could not get through snow. And so they developed this kit that they were going to put on, initially they put it on a tractor, but they actually did build it into Model T, I think it was a Model T, that they put these pontoons on the side and they did operate it in snow and inclement terrain. And it was not necessarily successful. They built about 11 of these things, but they used this specific tractor to maintain logging operations in northern Michigan throughout the winters in the 1920s. Actually 11 of them were built, and I think I've heard there's one of them around here. This is a picture of it. But the minute I saw this interesting little video on the internet, the gears just started clicking, and I thought, you know what, man, I would really like to turn this thing into a race car. And I took that idea and I ran back and I showed Professor Nagara, and he was like, really? It's a tractor, you know? So we talked about it, but I talked about it with some other instructors, and they had some good ideas, so I sketched on it. And after I had created a bunch of different ideas, I didn't know whether I wanted it to be kind of big and rugged or whether I wanted it to look light and nimble, because this is something that's going to take on a lot of different terrains. Do we want to make it light and nimble like a race car? Or do we want to make it look like it can take some abuse? So I went into Imagine and Shape, and I did some parametric modeling using some of the cone, what I'll describe later. And I created a series of models that I brought back and I showed in a sketch review. And I said, okay, do we want this one here that's more light and nimble, or do we want this one back here that looks like it can take a lot of abuse, or do we have this one that's kind of in between? I don't really know what we want to do. Well, it's a kind of a sketch review on steroids at this point, because really what we can do is we're not just looking at a bunch of sketches that kind of sort of go together, we're actually looking at a 3D model that we can spin. And so it gets people more excited about your idea because, as we say, or as I like to say, a picture may be worth 1,000 words, but a 3D model is worth 1,000 pictures. So this is what we eventually arrived at first. This one on the right, I wanted to use a kind of European design where the cockpit was up front and the power was in the back. I thought it would look more modern that way. And I'll never forget this, neither will Professor Nagar, because one of the guys who said to me, you know what, it's just not working for me. You need to lose those pods in the front, you need to put the power up front, you need to put the cockpit in back, you need to unbalance this thing. Race cars, fighter planes, they're all inherently unbalanced. You need to unbalance this thing and then it'll really pop. So why don't you do that and I'll come back tomorrow. And I said, no, wait, I'll do it right now. So I jumped into Imagine and Shape, and just as fast as I'm talking to you about it right now, I pushed the cockpit to the back, I went to Assembly Design, and I pushed the pods to the front, and I had this right here, and I looked at it and said, I don't like it. And he looked at me and said, you know what, save it and open it again tomorrow, I think you'll change your mind. And gosh darn it if I didn't. So what we did is we took that proportional model, and I started sketching over the top of that and adding details and trying to decide where I thought this could go if I were to try and keep this design, and we decided to pursue this. And I surfaced it out, just as our last presenter said, in GSD and Freestyle, because we didn't have Imagine and Shape on our computers at that time. Now we do. But learned how to get this whole shape. I wanted to do it solely in CATIA. I have that capability of making parametric updates. I wanted to do this completely in CATIA, so I used JSD and Freestyle in a significant portion of my summer to get what you see here on the screen. And I would be totally remiss if I didn't talk about Mr. Borchards's favorite part. He loves the pod. When I developed this pod, the whole idea was this device is going to go on water, on snow, on sand, inclement terrain. We wanted to create something that kind of looked more like a turbine on rails, something that could propel this vehicle, but still look like it could also push water. And when I started with the pod, I didn't really know what I wanted it to be, so I started to kind of experiment with the idea of making it very, very parametric. The outside diameter, the middle diameter, the length of the pontoon, the rail height, the number of helixes inside, all of this is parametric and updatable. And as I decided on different versions of my sketch models that you saw in Imagine and Shape, I also was able to control the parametrics of this rail and create something that was more pliable to the specific sketch model that we were looking at. In the end, we wound up choosing one of these variants, and I used this in order to save me a whole lot of time kind of remodeling this complex surface. And so all that's well and good, but what do we do with it when we're all done? Well, we take it out. It looks great here on the screen. It's a little dark up there. We put it into our realistic ray tracing softwares here. We use a number of them, not only CATIA here at Lawrence Tech, but and we create basically the fun. This is where we take our finished model and we light it, we make it look like something very realistic, and we put it on the internet and scare all our friends and say, this is what we do at school, and they say, oh my gosh, that's amazing. It's a lot of fun to show it to the underclassmen too. So after we're done with that, we can also take these models and use them directly in Photoshop, as I described earlier. In my case here, I did a couple of renderings where I just lit this thing in white. I let the shadows kind of take care of themselves. It saved me a little bit of effort. Also put it in perspective. I dropped this image here on the left into Photoshop, and then I do my Photoshop thing on top of it, and I try and depict it as a race car. I mean, basically what you see on the left is what I started with. What you see on the right is what I finished with. And that took me a Saturday afternoon. Same here on the right. I wanted to do something to depict it in its water environment, perhaps in a race. This was supposed to be meant as a race car. So I took the image on the left and tried to kind of Photoshop these guys up a little bit to get everyone excited about my idea. And then, of course, Ford, Professor Nagara got people at Ford so excited about my idea that they decided to build me a physical model of it. And it's not here, it's over in our design building. If you guys find yourself on a break, you can go out to the edge of campus and actually see it. Professor Nagara keeps it right outside his office, and it's actually 28 inches long. It's a very big model, it's very cool. We had it at the auto show, was it the year before last, and I got a lot of response to it. It's very impressive to see it in person, so if you guys get a chance before you leave school today, please go over to the Trans Design Building and do so. And the last thing Professor Nagara wanted me to show you was what we can also do when we have the CAD data. It's fun to create models and have something like that, but we can also take them into the other softwares that we know how to use here at Lawrence Tech. All students know how to do this and do this starting in their sophomore year. They create a finished video featuring their product. Sorry. And with that, I'll be quick, and thanks. Are there any questions I can answer about our program or what I did? Nobody? Oh.
What's the future of the sidewalk? What do you want to do with that?
Unknown. We've had some ideas, people have approached us about some ideas, taking it something smaller, something bigger. Right now it's a little bit in limbo, but we're developing it. This was actually a part of a co-project with one of my classmates. He built a completely jet-based design, and him and I may want to put something together regarding both projects. We always intended to do that, we just kind of ran out of time. We only had 15 weeks to do this. So him and I are now graduates, we've got a little time on our hands, we want to get together and make it what it was meant to be, a race.
And I assume you'll release more details once your copyrights and patents are all.
Well, I think the copyright's instant, isn't it? But yeah, patent-wise, I don't know.
It's a great idea.
Thank you.
Phenomenal innovation.